Okay, so 7.3 is radian measure. And we've already talked about unit circle. We've created the unit circle using all the degree measures. And we've talked about standard angle, which remember is you have the initial side that's on the x-axis and the terminal side that can be anywhere else in the circle. We've also done right triangle trig. So now we're just going to get into radians. A radian is just another way to measure angles. So let's start with some definitions. So central angle. So the central angle is an angle whose vertex is at the center of a circle. So basically the vertex is the middle, so the middle point. And then it's just any angle. So in this case, on our example, this is our central angle right there. And it's this angle right here. I'm just going to call that angle theta. So theta is our central angle. Then the intercepted arc is the the portion of a circle whose endpoints are on the sides of a central angle of the circle and whose remaining points lie in the interior of the angle. That's a lot of words. Basically, the intercepted arc, you take where your angle is and you look on the inside of where that circle is. So it's where it intercepts our circle. So right there is our intercepted arc. Pretty straightforward, not too bad, it shouldn't be. Let's just do another example. So if we have this angle, or this circle right here, let's just draw an angle. Let's say, so this is the center. Let's draw an angle right here. That's our angle. So this is our central angle. The intercepted arc would be this portion of the circle right there. That is our intercepted arc. If our angle was on the other side, so say that this was our theta on this side, this would be the intercepted arc for that theta, for that central angle. Okay, now let's talk about radians. So a radian is a unit of measure for angles. 1 radian of an angle made at the center of the circle by an arc whose length is equal to the radius of the circle. So basically, a radian, if you take your radius, this is our radius right here, your intercepted arc is the same length as your radius, and that equals 1 radian. So this right here, this angle is 1 radian, and the arc is also 1 radian. So here's an animation that will show you basically what a radian is. So if you look at this again, they started at the radius of the circle and it came out and it's the same length as our intercepted arc. So the angle is 1 radian and the arc is also 1 radian. So if you think back just to like yesterday, when we were talking about the unit circle, the full circle is 360 degrees. So that's 1 full rotation. So 2 pi radians is equal to 360 degrees. So we can use that ratio to convert between radians and degrees. So 2 pi radians is 1 full rotation. Full rotation. This right here, so this is very important to remember. 2 pi radians is equal to 360 degrees. Which means that pi radians is equal to 180 degrees, because you would just have to take half of 360, which would be 180, and that would be half of a rotation is pi radians. Okay, take really good notes on this part. So the general formula for converting from degrees to radians is to take the number of degrees and multiply it by pi over 180 degrees. So basically the formula is degrees times pi over 180. And then you go through and you simplify. So let's do an example. Let's say we have to convert 200 degrees to radians. So what we're going to do, 200 is our degrees. So I'm going to go 200, I'm going to multiply that by pi over 180. To simplify this, or to multiply, we have a fraction here, so I can just put this over 1. So I'm going to do 200 times pi, which is 200 pi. 1 times 180 is 180. And then I can just go through and simplify this. 20 can go into 200 and to 80. So 20 goes into 200 10 times. So it's going to be 10 pi. And 20 goes into 180 9 times. So 200 degrees is equal to 10 pi over 9 radians. So that's how we convert from degrees to radians. This right here is what I really want you guys to know. So to convert from degrees to radians, you have to take the degrees that you're given and you have to multiply by pi over 180. That will give you the radian measure. So these are the same radian, or the same measure. They're the same angle measure. This one is 200 is in degrees, and this is in radians. That's the only difference. Okay, now say that you're given radians and we need to convert to degrees. So now you're going to multiply the number of radians you're given by 180 degrees divided by pi. So before we multiplied by pi over 180 to convert to radians, so to convert to degrees, you multiply by 180 over pi. So let's just do an example of that. Or let me write this real quick. So it's radians times 180 over pi. So say you're given 4 pi over 9 radians, and we want to convert that to degrees. So you're going to go 4 pi over 9 times 180 degrees over pi. You're just going to go through and multiply this out. So you're going to do 4 times 180 is 720, and then the pi stays up there. 9 times pi is 9 pi. Then we can simplify this fraction a little bit more. Pi divided by pi is 1, so those cancel. 720 divided by 9 is 80, so it's 80 degrees. So 4 pi over 9 radians is the same thing as 80 degrees. Okay, last thing we're going to do is we're going to find the length of an arc. So this is our arc right here. We want to find that length. So for a circle of radius r, so this is our radius, and a central angle with the measure of theta in radians, so it has to be in radians, that's really important. The length of S of the intercepted arc is, so S equals r times theta. So it's basically it's your radius times the central angle. That's how you find this measure right there. That's how you find the intercepted arc. So let's just do an example. So let's just write down our formula again. Remember, so S, or your arc length, wait, my pen's not working. Okay, S equals R times theta, where this is your radius, theta is your angle, and S is your arc. So here, let's find S. So we want to find this length right there. So we're given our radius, so R equals 3, theta equals 5 pi over 6, so what does S equal? What we're going to do is we're going to go S equals R, which is 3, times 5 pi over 6. Then we're just going to go through and multiply this out. So 3 times 5 is 15 pi over 6. Then you can put that straight into your calculator, and it will give you 7.85. That is this measure right there. Okay. We could do the same thing and go and solve for B. This time with B, though, our angle measure is going to be different. The radius is the same, except for our angle measure this time is going to be 2 pi thirds. So we're going to take, so B equals 3 times 2 pi over 3. And then those 3's are going to cancel. So we're left with b equals 2 pi, which is 6.28. Cool? So the biggest things I want you guys to remember from this is how to convert from radians to degrees, degrees to radians, and the formula for finding the length of an arc. Remember, you don't even have to remember it as a formula. Just remember that it's the radius times the angle. So the length of the arc is always the radius times the angle. Okay, if you need to go back and look at those other formulas for converting to radians and degrees to radians. We're going to be doing this a lot tomorrow, so just make sure you can do it. Thanks. Make sure you take the video, or take the quiz. Oh my gosh, can't talk. Okay, bye.